Hello and welcome to my channel, Hardware.ai. Today we're going to be talking about PYNQ Z2 FPGA Development board, which can be programmed in Python language. First of all, let's have a quick overview of what is an FPGA. FPGA stands for Field Programmable Gate Arrays. Field Programmable here points at the fact that their internal logic can be configured by a designer or customer after manufacturing. FPGA contains an array of programmable logic blocks, a little bit of high-speed memory to hold the data in use, some dedicated circuits for mass operations, and dedicated blocks for input and output operations, among others. If you think the name FPGA is a little bit difficult and confusing, I can understand you on this one. You could call them generic hardware blocks that can be reconfigured with a software. The best comparison for FPGA I found on the internet was a box with Lego blocks, which you can use to build your own designs. A processor, a CPU, accomplishes its tasks, for example, editing pictures or playing music, decoding a video, by executing instructions in a sequential manner, one by one. This means that the processor's operations are inherently constrained. The desired functionality, like editing a picture, must be adapted to available instructions, and in most cases, it is not possible to accomplish multiple processing tasks simultaneously. Unlike CPUs and ASICs, where digital logic is already implemented on the chip, FPGAs can be programmed to implement the digital logic in the hardware using configurable logic blocks, or CLBs. You can cleverly use the generic hardware inside the FPGA to perform specific tasks in a parallel or pipeline fashion in far less time than a typical CPU could do so in a typical one instruction at a time fashion. This makes FPGA great for certain kinds of real-time jobs that must create or process very large amounts of data rapidly. For example, real-time signal processing, high frame rate video processing, and hardware-accelerated algorithms, including machine learning algorithms. Two main manufacturers of FPGA chips are Xilinx and Altera. Altera was acquired by Intel not so long time ago. The board I'm going to be reviewing today is called PYNQ Z2, and it is built around PYNQ Z2 system on chip, which includes dual-core ARM Cortex-A9 processor integrated with 28nm RTX-7-based programmable logic. Programmable logic here is an FPGA. This combination of ARM processor and an FPGA enables quick prototyping of programmable logic designs. What it means for you is that you can use PYNQ Z2 as a regular development board running Ubuntu image, and for parts of your application that require hardware acceleration, for example, machine learning or signal processing, you can access the programmable logic using its Python libraries. There are many FPGA boards available on the market, but PYNQ boards are one of the most user-friendly ones. There are a lot of examples and demos that you can run in Jupyter Notebook, which is a browser-based interactive computing environment. Overall, I found it's easy to get started with using programmable logic and hardware acceleration on PYNQ boards, even without prior extensive knowledge of FPGA programming. Next, we're going to have a quick look at the board, its hardware specs, and the interfaces available. And then I will go through the first boot procedure and run some neural network acceleration demos on this board.